So we've looked at graphing different equations, and there are different types of symmetries whenever you go to look at these graphs. So we're going to talk about the three different symmetries of graphs. So the three symmetries. Along with these three symmetries, we're going to look at how do you tell if it's symmetric by looking at the graph, but then also algebraically, what do you do? So the first type of symmetry is being symmetric about the x-axis. So being symmetric with respect to or about the x-axis means I have a graph. Here's my x-axis, here's my y-axis. The x-axis kind of acts like a mirror. So anything that's above the x-axis is repeated below. So something like this. You can see that the x-axis is kind of like a mirror, and that tells me that it's symmetric about the x-axis. Second type, symmetric about the y-axis. So with symmetric about the y-axis, this time the y-axis is acting like my mirror. So something like this. You can see that if I flip my graph across the y-axis, I get exactly the same graph. So the y-axis is acting like my mirror, and you can flip it across and it's exactly the same. The last one is the origin. So the origin is kind of like a combination of the x and y. It means that I can flip it across the x and then also across the y, and I should get the same graph. So something like this. You can see if I kind of flip this top part across the y-axis, I get this, and then flip it across the x-axis to get this. So that's how you know it's symmetric about the origin. I should be able to flip it across the y and across the x, and that'll give me symmetric about the origin. So let's talk about how do you do this algebraically. So if I want to know if an equation is going to be symmetric about the x-axis, if you notice, so here's our graph for being symmetric about the x-axis. Whenever I have an x value, there are kind of two corresponding y values, the plus and the minus. Okay, so what that means for us is in the equation, replacing a y with a minus y should give me exactly the same equation. So what we're going to do to determine this is, one, we're going to replace y with negative y. And that's coming from here's my y and here's my negative y. They should give me the same answer. So replace that. Then we're going to simplify. When I say simplify, I mean using things like negative x squared is the same as x squared, or negative y to the fourth is the same as y to the fourth. So we're going to simplify and then compare. So we're going to compare our beginning equation to what our equation now is that we simplified it and replaced. So for example, let's look at 4x plus 2y squared equals 5. I want to know, is this symmetric about the x-axis? So symmetric about the x-axis. Well, let's see. I have my original equation. For the x-axis, I replace y with a negative y. So everywhere I see a y, I'm going to replace it with a negative y. Now I'm going to simplify. It doesn't matter if you square a negative number versus a positive number. It's going to give you the same result. So this negative y squared is the same thing as just y squared. So I can simplify it that way. Now compare. Are these two the same? The answer there is yes. So yes, it's symmetric about the x-axis. So now that we know how to do symmetric about the x-axis, let's look at symmetric about the y-axis. In our picture here, something like this. So in our picture, for any y that we kind of have two corresponding x's. So just like with the x-axis, we wanted to replace y with a negative y, we're going to do the opposite now. So instead of replacing y with negative y, we're going to replace x with negative x because of these two. The two x values, negative and positive, should give me the same y. So that's why we care about that. Then we're going to simplify, and then we're going to compare. Just like we did with the x-axis, only now we're replacing x with negative x instead of y. So for example, is the equation 4x squared plus y squared equals 8 symmetric about the y-axis? Well, let's see. To determine if it's symmetric about the y-axis, I'm going to write my equation down. And now you have to decide, what do I replace? Well, for the y-axis, we're going to replace the x. So everywhere I saw an x, I just replaced it with a negative x. Next, we're going to simplify. Remember that when you're squaring, it doesn't matter if it's negative or positive. It's still going to give me the same answer. So this is the same as 4x squared plus y squared equals 8. Now that we've simplified, let's compare. So are those two things the same, those two equations? The answer there is yes. So our overall answer, yes, it's symmetric about the y-axis. So we've done x-axis, we've done y-axis. Now let's talk about the symmetric about the origin. So the picture that we kind of have in our head is something like this. Anytime I have an x, there's a corresponding y. But then also, that same x got flipped over here to the negative part, and that y got flipped down here into the negative part. And there's this corresponding point. So what we're going to do to talk about symmetry of the origin is you replace both. So we're going to replace x with negative x and y with negative y. Simplify, and then compare. And that's because, if we go back to this picture here, I know it's a little bit messy, but whenever we were drawing this, I would kind of have my top part here, then I would make all of my y's negative, then I would make all my x's negative, then I would make all my y's negative to get the rest of the graph. So symmetric about the origin, I'm going to do both. So for example, let's look at x plus y equals 4. Is this symmetric about the origin? So I'm going to write my original one down. For the origin, I'm going to replace both. I'm going to replace x with a negative x and replace y with a negative y. So there I have that. Simplify it, well, the only thing we can really simplify is negative x minus y. Now look at these two. Are they the same? So the answer there is no, they're not the same, so it's not symmetric about the origin. Let's look at one more example of this. Is the equation x equals y cubed symmetric about the origin? Well, to test symmetry about the origin, I'm going to write down my original problem, replace x with negative x and y with negative y, and now we're going to simplify it. Well, there's not really anything we can do with that negative x, so we're just going to leave it. But now think about what negative y cubed is. That's negative y times negative y times negative y. Well, there are 3 of them, so definitely y to the 3rd power. 2 of the negatives will cancel, and I'm left with 1. So this is negative y cubed. I think we can simplify this one more step divide both sides by a negative 1. So I get x equals y cubed. If you compare the simplified to the original, they are the same. So my answer here is yes. So just remember, if you're talking about symmetric about the x-axis, replace y with negative y. Symmetry about the y-axis, replace x with negative x. And the origin, replace both.